Section 4.4 is going to go over two more ways to prove two triangles congruent, and this is ASA and AAS. Before we can get into it, we need to discuss included side. So by the diagram, you can say that an included side is the side between two angles. And these are my two angles, whether they're congruent or not. This would be my included side. So the angle side angle congruence postulate will say, if two angles and an included side of one triangle are congruent to two angles and an included side of a second triangle, then the triangles are congruent. So once you have that down, I want you to come over to your diagram, and let's call the first triangle ABC, and let's call the second triangle DEF. And if this is going to be an example of angle side angle, you would have two angles congruent and two other angles congruent, and the side in between those two angles congruent. And then you can make the statement that triangle ABC is congruent to triangle DEF. On example number 1, it says to determine whether the following triangles are congruent due to ASA, and if so, write the congruent statement. So we have an angle congruent to an angle, and then we have a second angle congruent and the side in between. So I would say yes, by angle side angle, those two triangles are congruent. Now be careful when you make your statement. If I call the first triangle ABC, so first I'm naming the angle that's not marked, so I have to go over to my other triangle and start with the angle that's not marked, so triangle N. And then if I go to the single notch on my first triangle, B, I have to go to the single notch on my second triangle, so that would be M, and then C would correspond with L. Triangle ABC is congruent to triangle NML in that order. Now, you need to remember that if I call the first one ABC, my second one has to be NML, but you could go ACB, and if in fact you start a different way, it's okay as long as you would go, if I said ACB, you would say NLM. So just be careful and be consistent with the markings. Example 1B, do these two triangles on the diagram look like they're congruent by angle side angle? Well, it doesn't look like I have enough marked, but I do know I have a set of vertical angles in here, which we know are congruent. So now it looks like angle side angle does work, and my statement might be that triangle NMT, if I'm naming the top one first, NMT, would be congruent to triangle DAT. Okay, over on the back, the angle side congruence postulate says if two angles and the non-included side of one triangle are congruent to two angles and a corresponding non-included side, I'm sorry I didn't leave you enough room on the paper to put that in, so just write it above a little bit, of another triangle, then the two triangles are congruent. So this is what it means. Let's label up our triangles, ABC and DEF. And what it means by two angles and a non-included side, if A and B are congruent to D and E, and a side that's not between the two angles, but maybe the side over here, side BC, is congruent to the corresponding side, so it would be EF, then you have what's called angle-angle side. And your statement would be that triangle ABC congruent to triangle DEF. Now, you could, if you didn't have this side BC congruent to EF, it would also work if you had AC congruent to DF. So that would also be an option. What would not be an option if you were using angle-angle side is that the AB is congruent to the DE. That would not work. So for example number 2, take a look at those triangles and decide if you think those two triangles are congruent by angle-angle side. Well, I have a right angle congruent to a right angle, and I have an acute angle congruent to an acute angle. So there's the angle-angle part. And what's not marked, but what's true, is that they share a side. So I would say yes, angle-angle side does apply, and triangle ABC is congruent to triangle DCB. For part B, pretty much the same thing. You have your two angles congruent to two angles. You don't have any sides marked, but you do have a side that the two share. And so by angle-angle side, again, I have triangle LMN is congruent to triangle ONM. Okay, so now we're going to apply this to a proof. So we have some given information, and we're trying to prove that the two triangles are congruent. So I'm going to set up my T with my statements on the left and my reasons on the right. And I'm going to go step by step. Number 1. I've been told that angle S is congruent to angle Q. It's marked on my diagram, and it was given information. For statement number 2, I was told that the segment RP bisects the angle SRQ. That was also given to me. Well, the word bisects means cuts in half. So if this segment is cutting the big angle in half, it means this little angle is congruent to this little angle. So statement number 3 is going to be that angle PRS is congruent to angle PRQ. And the reason why I know that is because I know the definition of bisect. Now, that's all the given in the problem. So now I have to resort to what I see in the diagram. And what I see in the diagram is that the two triangles share the side PR. So I can say side PR or segment PR is congruent to itself, and My reason is the reflexive property, since anything is congruent to itself. And now I do have enough to finally say what I'm trying to prove is that triangle SRP is congruent to triangle QRP. And my reason? Angle, angle, side. Okay, example number 4 is over on the last page. We have another proof. And so we want to set up our T, our statements and our reasons. And statement number 1 says that the segment XQ is parallel to the segment TR. That was given, and on my diagram, that's what these little arrows are showing me. Now, before I go to the next given, what I want to say here is that I have a set of alternate interior angles that are congruent. I learned that in chapter 3. When I have parallel lines and a transversal, alternate interior angles are congruent. So I'm going to say angle Q is congruent to angle T, and my reason is alternate interior angles are congruent. If you don't want to write quite so much, you can abbreviate, as long as when you look back at it, you know what you're saying. Now, this little comma here is a mistake. That's a typo. So my next information is that segment XR bisects segment QT. That was given information to me. And if I go over to my diagram and I see that QR is cutting QT in half, then it must be true that QM and TM are congruent. So step number 4 is QM is congruent to TM, and that's because I know the definition of bisect. And at this point, it looks like I don't have any more given information, so I have to resort to the diagram, and what I can glean from the diagram is that I have a set of vertical angles that are congruent. And what I'm going to say for step number 5 is that angle QMX is congruent to angle TMR, because I know that vertical angles are congruent. And now I do have enough information to say that triangle XMQ is congruent to triangle RMT. And my reason this time would be angle, side, angle, ASA. Alrighty, and that should do it until next time.